Hello, I'm Edmund Storms, and I'm here in my office in Santa Fe, New Mexico on a cool day in December 2007. I would like to tell you about cold fusion. Cold fusion is the most important and underappreciated discovery of this century. In fact, this discovery has the potential to change the lives of everyone on this planet and provide clean, cheap energy for the foreseeable future. Well, now that I have your attention, I'd like to justify this statement during the next 50 minutes. But first I need to explain the meaning of the term cold fusion. This term was applied to the discovery made by Professors Fleischmann and Pons in 1989. Here you can see the pair holding one of their cold fusion cells when they were much younger and ignorant of the events they would suffer. Growing understanding makes cold fusion a very inadequate way to describe the process. Nevertheless, I will use the term because it is a name that most people associate with the discovery. Presently, several other names are also applied. This phenomena called cold fusion is the popular name. Low energy nuclear reaction, LENR, is now the general description. I like to use the term chemically assisted nuclear reaction because it better describes the environment in which the phenomenon occurs, and this is CANR. At the present time, condensed matter nuclear science is the name of the field of study. That's CMNS. The idea of cold fusion creates a mixed reaction in people. Non-technical people, when they learn about the phenomena, recognize it as a possible ideal energy source. The process makes energy without producing radioactive products or carbon dioxide, and it uses deuterium, which is not radioactive and is plentiful in all water. In addition, the process is simple and can be easily made to occur on a small scale for local use. These features make the process very attractive, especially in view of the need to stop adding carbon dioxide to the atmosphere and to stop accumulating dangerous radioactive material from the fission reactor process. In contrast, most scientists who know about the claims think they are nonsense for various reasons. The effect has been difficult to produce. Such a fusion reaction is believed to be impossible at such low energy, and the theories that have been proposed to explain the results are filled with unacceptable assumptions. Many less rational reasons are also used, but I won't go into these just now. Even if cold fusion is unlikely to be real, the collection of growing problems such as global warming, the need to desalinate seawater for irrigation and domestic use, and the increasing cost of oil and uranium should be enough to encourage studies to see if the skeptics are correct or not. Work is being done in a number of countries: Japan, Italy, Russia, the Ukraine, Israel, United States, China, and France. Most of the work and developing understanding is now taking place in Japan and in Israel. So, we have an interesting situation. We have an energy source that, if real, can solve some important problems we now are facing. On the other hand, many people who are in a position to support development of this source of energy think the claims are based on bad science. My goal today is to show you that cold fusion is a real phenomena, and it has the potential to be the energy of the future. Forgive me if you already believe that cold fusion is real and just want to learn what is presently known. I will provide such information as I go along, and so you won't be disappointed. Before starting, we need to understand exactly what cold fusion claims to do. When deuterium fuses with itself or with other elements, a lot of energy is released. A couple of fluid ounces of liquid deuterium would provide all the energy a person would need to support the standard of living existing in advanced countries, including transportation, for a lifetime. The amount of energy available is much greater than from uranium and the fission process. Now, these reactions can take various paths. The fusion reaction can take three paths. The first forms helium-3 and a neutron. The second forms a proton and a triton. These two paths take place at high energy in plasma and a hot fusion reactor. They occur more or less in equal amounts. In contrast, the cold fusion process results in helium-4, but no gamma. So you can see that the environment plays a big role in the paths that the reaction takes. In addition, at low energy, another reaction takes place where a number of deuterons combine to enter the nucleus of a heavier element to produce what would be a fusion reaction, and this may or may not be followed by fission of this more heavier element. This reaction is called transmutation. Not detected is the fusion between a deuteron and a triton, producing a neutron, and the fusion between a deuteron and a proton, forming helium-3. As you notice, the path changes as the conditions change. This fact is very important, and it means that failure to see a behavior observed at high energy cannot be used to show that fusion is not occurring at lower energies, typical of the cold fusion environment. Normally, neutrons and gamma radiation are not detected outside of the apparatus. This lack of expected radiation is one of the reasons the whole idea is rejected by some people. For them, no neutrons mean no fusion. On the other hand, this gift of nature is very welcomed by people like me who study the process, and it should be welcomed by people who may make use of the generated power in the future. The absence of dangerous products and the simplicity of the equipment needed to cause the fusion reaction makes the method attractive as a source of energy for each house. Space heating would simply use the generated heat. Direct conversion of heat to electricity without moving parts could be done using thermoelectric converters. This could supply electric power for domestic use and personal transportation using plug-in hybrids. This is only a small fraction of the advantages such a source of energy would provide. In contrast to cold fusion, a hot fusion program called ITER now is underway in France. The hot fusion process requires the use of a very large device, heat generator, energy generator. You can see the size by comparing it to an ordinary person. The fusion reaction occurs in this space, which is surrounded by very intense magnetic fields to keep the hot plasma away from the walls of the apparatus. This generates a large number of neutrons, which are then captured outside of the apparatus to convert the neutron energy into tritium, which is then fed back into the machine to institute further fusion reactions.